So we've talked about floats, float 2s, float 3s, and float 4s. These all hold sets of floating point numbers. Now let's talk about a type of container that's a bit more advanced. It's called a struct, short for structure. A struct is a container that can hold several other data types. It's similar to a data type, only at a higher level. So to start off here, let's get rid of all of this sample code. And the first thing that we're going to do, before we can create a struct, we have to define the struct itself. So to do that, I'm going to go struct my sample struct. Then I'm going to make some curly braces, and the data that the struct holds goes inside the curly braces. So this struct is going to hold a float 3 named Jim, a float 3 named Chris, a float 2 named Adam, and a float named Matt. So now I've defined my struct, and I've told it what data goes inside. And you'll probably notice that I haven't given the members of the struct any values yet. That's because this bit of code doesn't actually create the struct, it just defines what the members of the struct are. And it sets up a template for me to make structs of this type in the future. Structs are more custom than data types. With data types, the definition is built in. With the struct, you have to define it yourself first, and then use that definition to create structs. It's sort of like making a mold for the container. So now that we've defined our struct, or created a mold for our struct, let's create the actual struct itself. And here's how we do that. My sample struct Ned. Okay, so I've created Ned, which is our sample struct. Oh, you have to end a struct with a semicolon as well. There we go. My sample struct Ned. So I've created the struct, but I haven't given it any values yet. If I try to access the data in the struct at this point, I'll get errors, so I need to fill in the data. And here's how we do that. Ned.Jim equals, and we notice up here that Jim is a float 3, so we have to say float 3. We have to fill in Jim with the float 3. 0.2, 0.7, and 0.1. Just give it some random numbers here. We'll go Ned.Chris equals float 3. Now you notice that Chris up here is also a float 3, so we're giving Chris a float 3. Float 3, 0.5, 0.3, 0.4, and with the semicolon, Ned.Adam equals float 2, and Adam's a float 2, so we'll give him a float 2, 0.8, 0.8, and 0.9. Finally, Ned.Matt equals 2.0. And since Matt's just a float, we don't actually have to tell it what data type. We just give it the number directly. So now that the struct is filled in with data, you can access the individual components in the struct much the same way you can access the components of a float 3 or a float 4. So here's some examples. Float 3 Josh, a new float 3, equals Ned.Chris. What that does is it takes the value of Chris and assigns it to our new float 3 Josh. Here's another example. Float 2 Dan equals Ned.Adam. So Adam, the Adam component of our structure Ned, is a float 2. So we take that float 2 and we assign it to Dan. You can also go farther and access the individual float components of each member of the struct. Here's some more examples. Let's go float Joel equals Ned.Adam.x. Whoops, .x. Okay, so we've got ned, which is our struct, atom, which is our float2 inside the struct, and .x. So atom's first component, which would be 0.8. So now float joule is equal to 0.8. And here's a little bit more complex example. Float3 bill equals float3 ned.gym.y ned.chris.x and ned.map. So, given bill a float3, first component is ned.gym.y, which would be 0.7. Second component is ned.chris.x, which would be 0.5. And the third component is ned.mat. Since ned.mat's just a float, that's obviously 2. So notice here how I'm going from the struct level to the data type level and right down to the component level, that each level jump is separated with a period. Structs are a convenient way to store a set of data. For example, a light source has a color, a position, and maybe some attenuation values. If it's a spotlight, it also has a direction and a width. You could create a light source struct that held all these values to simplify the process of working with the light source information. So, for example, you could type struct my light source, right? And it could have color, and it could have a direction vector, and some other elements possibly. So you would type here my light source ned, so your light's name is ned, and then ned.color would be this color, and ned.direction would be the values for a direction vector. So that would be an easy way of grouping all of the data of the light source together and then assigning the values individually. Alright, now let's take a look at our shader and see how structs are actually applied. Scroll up here toward the top, and you'll see that's this section called shader structs. This first struct here is input from the application. So what we're doing here is we're pulling in the position of the vertex from the CPU. So when we talked about the data flow from the CPU and through the GPU, and we talked about how there's certain data that comes in, this is the data that we're coming in, or that we're telling the shader to pull in. If we wanted to, we could tell it to pull in vertex color, UVs, vert normals, other information as well. But right now, our struct called app2vertex is only pulling in position. So if we look down here in our shader, we're saying in.position. So in is the name of our struct, and position is the position component. So we're pulling in the position of the vertex and doing some math on it. Now here we have output to pixel shader. This is a struct that defines the data that we're passing out from the vertex shader to the pixel shader. You can see that the components of this struct are both position and color. So jumping back down here, the name of our struct is vertex to pixel. So we create vertex to pixel and call it out. And then this line here actually sets all the values in this struct to 0. So here we go. Out.position, which is this, equals in.position, and then we multiply it by some stuff. And we're going to talk about this part in the next chapter. And then down here at the bottom, out.color equals this float4 color value. So what you can see is we've set up our output struct with both position and color, and then what our vertex shader is doing is filling in those values. And then that structure gets passed on to the pixel shader. So in an effects shader, structures are used for inputs to the vertex shader outputs from the vertex shader to the pixel shader, and you can also use them for anything else that needs groupings of data types.